Hey, what's up everyone? Vegetarian Zombie here, and I want to welcome you back to my Beginning Unity with C# series. Before we dive into business, let's review our last assignment. The task was to create a very simple Mad Libs. To demonstrate this, we're going to look at this in MonoDevelop. This is where my project was last left off. And I just want to note that I'm making a few production changes within this series. Previously, I worked on a much higher resolution and then I zoomed in so that you could see it closer. Now I'm setting my resolution a little bit smaller and I've increased the text size. This is not only so you can see things a lot clearer, but also so that you can actually see the compile errors as I run into. Learning to see compile errors and how to respond to them is actually very important when developing. So I think this is going to be a much better approach in that way. There is unfortunately one disadvantage. MonoDevelop is kind of a weird IDE. It does not support things such as text wrapping. So as you can see here, my text just scrolls right off. The way I can get around this is I can hit enter here. As you can see, it moves on another line and you can see it clearly. This also helps on a visual level so that you can see how the compiler sees our code. You can see that the line break doesn't affect the code whatsoever. The compiler simply ignores white space. So here I can add as many lines as I want, and that's still going to compile without any issues, but it may look a little weird. So we try to make things as compact and as easily to understand at a visual level as possible. Okay, let's get back to the task. The task was to create a simple Mad Libs, and what I'm going to do is I'm going to delete all this stuff here. Next, I'm going to create a series of variables. Here we have 4 variables. The first one is a string, and if you remember, string is just simply text that we're storing in a variable. And that's the name. Next, we have the favorite food, which is also a string, and then we have an amount. In the actual Mad Libs challenge, I put forth using an unsigned integer as opposed to a regular integer, so we're using a uint. But typically speaking, if I was actually doing this in a real game or a real app, I would simply just use an int instead, unless there was a specific reason that I would use an unsigned int. And then finally, I'm using a Boolean value, which is likes to share. A Boolean value is, remember, a true and false value. And you can see the way I named the variable likes to share is either true or false. You could use just the word share, but that doesn't really emphasize that it's a Boolean value. I like to make my Boolean variable names like questions that the actual value answers. So if, say for instance, we had a game that had the player being alive, instead of just using an alive variable name, I would name the variable is alive. Okay, with that set, we're going to now write out the actual sentence. Here I'm putting my name is, and then I'm closing the quotation marks and then putting the variable name like so. MonoDevelop will sometimes try to get ahead of me and then autocomplete in very strange ways. If this is still somewhat new to you, then I highly suggest you rewatch the past videos because I go over this syntax. Here we go. I'm going to save this. I'm going to build this. Again, I don't have to build, but this will catch any issues that might be presented. Here you can see this name is causing a warning. The reason for this is that there's another variable called named used also within Unity. To just simply get around this, I'm just going to call this my name, and this will avoid this warning and any issues that warning may provide. Warnings are really important to pay attention to. They're not exactly errors, but they actually will point out an error that may result as a result of your code. I'm going to switch back to Unity. And then I'm going to select my cube, and you can see we have our script. Here I'm going to say Brian. My name is Brian. My favorite food is pizza, and I like to eat it a lot. And I like to share, and I like to share. Now I'm going to run this, and we will disable the cube. My name is Brian, and my favorite food is pizza, and I like to eat it 1,000 times a day, and I like to share it. And we're running out of space here. I'm going to close this tab, see if we can get some more. True. There we go. Here's our Mad Libs and our incredibly run-on sentence. Today's topic is operators. And operators is a very large topic. In fact, I could spend many videos just covering all the various aspects of operators. But the way I figured I was going to do this is I'm going to cover the most important parts of operators in this video. But as we move forward throughout the series, I'll bring up some important parts that later will make sense in the context that you'll learn it. If I covered everything here, it wouldn't really make sense at all. Believe it or not, you've been working with operators already. This is a fundamental part of C#. Let's take a look at some common operators that you will have already seen. Here you can see we have the equal sign, the plus sign, the minus sign, the multiplication sign, and the division sign. These are all operators that you'll be using. There are lots of other operators as well, and you'll discover these as you play around with C#. Let's start at the very top, and the first one is the equal sign. The equal sign, you've seen, we've created a variable name and we've assigned a value to it, and that should give you a hint at what this operator does. If you're coming from a math background, your first thought is that the equal sign denotes equality. This is not how the equality operator works in C#. The equality operator is an assignment operator. We're taking a value and we're assigning it to a variable. Let's look at an equation. Here we have x equals 1. We're taking the value 1 and we're storing it into the x variable. Now let's look at this in another way. Here we have an expression, int x equals 1. We're taking the value of 1 and we're assigning it into the x variable. If you're approaching this from a math background, that equal sign looks like we're making this equal comparison. For instance, x is equal to the 1 value. So x is 1 and 1 is 1. But this breaks down when we start doing other assignment operations. Let's take a look at another operation. Let's say we wanted to increment x by 1. Here you can see we have x equals x plus 1. We're taking x, we're adding 1 to it, and then we're assigning it back to x, thereby overriding the previous value that was contained within x. If you approach this again with a math approach, it would just simply break down because x could never equal x plus itself. That if you start thinking about it, you'll just go crazy. So just keep in mind, equals in C# is always used for assignment operations. Incrementing variables by a certain amount is a very common operation. In fact, we do it so much, there's shorthand inside the language for doing this. Instead of writing x equals x plus 1, we can instead write x plus equals 1. And this is just a shorthand way of writing x equals x plus 1. Now, you don't have to do x plus equals 1. You can do x plus equals 100 or x plus equals 1,000, or you can do x minus equal 1 or x times equals 1 and so forth. Again, this just makes it easier to write out these common operations. But believe it or not, we can even get smaller than that. Instead of using x plus equals 1, we can use these two other operations. One is a prefix operator and the other is a postfixed operator. Or you can see them here as plus plus x or x plus plus. Here's where things get a little bit dicey. And I'm going to walk you through these operators right now, but my suggestion is, especially as beginners, is not to use them. You may run into them in code, but they're kind of gnarly and they can cause some issues that you may not be aware of. Here, let's just break them down so you can understand. The first one is plus plus x. What this is doing is adding 1 to the value of x. That is the same thing as writing x plus equals 1 or x equals x plus 1. The postfix operator does the same thing. It adds 1 to the value of x. But the question is, when does it add 1 to the value of x? Imagine you had an expression that read y equals x plus plus. Can you guess what's going on here? Well, let's say x has a value of 1. Can you guess after this expression what the value of y and what the value of x would be? Well, the value of y would be 1. And then the value of x will be 2. What is happening is that the value of x is being assigned to y first. Then this operator increments the value of x. Thus, the value of x after this expression is then 2. You can think of this as 2 separate statements happening in one line. Typically, you'll see this happen in loops where it's important to iterate this variable as you're looping through, but not affect the other variables in the expression. But again, it can be very confusing, and oftentimes you may forget the difference between a postfix and a prefix operator. So this is why I suggest you just don't touch them. Simply use x plus equals 1, or rather just defer to x equals x plus 1. A lot of time as programmers, we like to be clever and we like to keep our code short, and these operators can help us do that. But there are some times where we simply create a trap of our own making. And then after extensive testing, you discover you were using the postfix operator when you should have been using the prefix operator. To avoid those type of errors, just avoid using them entirely. Next, we're going to return to the plus sign. You've already seen it used in action. You've seen how you can increment the value of integers, but you've also seen how it can be used in relation to strings. If you take 2 strings and you use the plus sign, it will concact those strings together. It will add them together and create a new string. Later, when you're working in Unity and you're working with vector 3 objects, you'll see that the plus sign will actually add 2 vector 3 objects. There's nothing magical going on here. As you advance with C#, you can actually provide your own behavior to these operators. You can create your own custom objects that will work with these operators in the way that makes sense. But that's an advanced topic, and we'll be covering it later in this course. The plus sign does bring up some interesting issues. Let's imagine we had an integer called x, and this variable is 10. And then we had an integer called y, and this variable is 5. Both of these numbers can fit into a byte. So let's imagine we want to add these 2 numbers together and store the result in a byte. Okay, that makes sense. We have 5 and 10. 15 is within the range of a byte. There should be no problems whatsoever. What happens is you're adding 2 32-bit numbers and then trying to store the result of that addition in an 8-bit number. That's not going to fly. The compiler is going to catch that for you because it thinks that's going to be an error. And the reason is you're going to be losing 24 bits during this process. To go forward with this, you have to cast the result of that addition. You've already seen casts with floats, but now we're going to do a cast with a byte. The way we do this is we put in parentheses our addition. So we would put x plus y within parentheses. That resulting addition is going to return an integer number, which we then cast to a byte. Outside that addition, we put in parentheses byte, meaning we're casting it down to a byte. And if we lose information, well, that's okay. We're fine with it. All that cast is doing is telling the compiler that we approve of that loss of precision, and that it's basically saying, okay, you're the boss. I'm going to cast it to a byte. You're going to lose data, but you're okay with that. This is true with, say, working with 2 doubles, and you're trying to store the result in a float, or other types as well. Next, we'll move on to multiplication and division. Multiplication and division work pretty much the same as you would expect. And remember, when you multiply 2 integers together, they'll return a whole number. And if you multiply a float or a double, they'll return those floating point numbers as well. When working with multiplication and division, you have to keep in mind the order of operations. Typically in social media sites, you'll see a problem posted like this. If you're a genius, you can figure this out. And it's like 1 plus 2 times 0 equals what? And if you don't remember your order of operations, the first thing you're going to say is 0, because you're going to start from the left-hand side and move over to the right. And you'll see that times 0, and it's like, it's times 0. But no, the answer is actually 1, because you first take 2, you multiply it by 0, and then you would add the 1 to it. That's following the order of operations. Division and multiplication have a higher precedence than addition or subtraction. And that's really the important thing to remember when working with C#, because if you need to do stuff that is playing around with the order of operations, don't defer to the expression, but rather you can use parentheses. Parentheses have an incredible high order of precedence. So you can take numbers, surround them in parentheses, and then it makes clear what's going on a mathematical level. Personally, I don't like to have a lot of operations occurring on one line. The reason is, as I'm going through my code and I see this complex formula, I then have to unpack it mentally to see what is going on here. Typically, what I like to do is break it down onto individual lines, and then I can see what's going on at a glance and then make any changes as necessary. But in cases where I do have to write complex formulas, then I will defer to using parentheses as opposed to relying on the order of operations. One last operator I think I should mention is the modulus operator. This operator simply gets the remainder of something. Let's imagine you have 2 ints. You're taking 7 and you're dividing it by 5. Your division, if you had done this division, the answer would be 1. But if you want to know the remainder of that operation, you would put 7 modulus 5, and the answer would be 2. Because after you divide 5 by 7, the remainder left over is 2, and that's what's going to be returned. One typical use for the modulus operator is to determine if a number is even or not. You'll take a number, you'll modulus 2, and if the result is 0, then you know it's an even number. If the result isn't 0, then you know it's an odd number. Okay, with all that said, let's jump back into code and just demonstrate some of these things. I'm going to do everything inside the onDisable method here. First, we're going to demonstrate our x variable, and we'll have it to say, actually we'll make this 100. And here we'll increase the value of x. The longhand way is to do x equals x plus 1. Now we'll do a shorthand method as well. There's x plus equals 1. And I'll just copy and paste this. And then we can do plus plus x. And we'll do something interesting for this. We'll do x plus plus. The value of x here will be incremented, but it will be the same as the previous line. I'm going to save this and build it. And to make things clear, I'll quickly just add these. Now I'm going to return back to Unity. We're going to stop this. And we're going to run. We'll disable. And you can see here, x equals x plus 1 is 101. X plus equals 1 is 102, plus plus x is 103, and you can see here, x plus plus is 103. We're taking the value of x, passing it into the string, and then we're incrementing it. And then when we print out x, you can see it was set to 104. Returning back here, let's do an example of working with ints. Returning back here, let's now add ints and store the results in a byte. Here we have y equals 20. And then if we want to do a byte z, we would have to put these x plus y. And you see if I save it now, I'm going to get a cannot complicitly convert an int to a byte. Again, I would just simply put byte like so. And now I can just print out the result. There we have Z is 120. And lastly, when working with a complicated formula like so, here you can see we're dividing 100 by 200. Here you can see we're multiplying 100 by 200, then dividing it by 2, and then adding 10 to it. In this case, this makes sense, but if I did something like, in this case, you would start from the left and then move over to the right. In a better way of writing this would be to do something like this. Now you have a clear idea of what's going on. You start in the middle parentheses and you work your way out. And one thing I'd like to mention is oftentimes you're going to be writing code and you're going to forget what's going on. And one way to help remember is to write comments. A comment is simply these 2 forward slashes, and then you can put some text after this. The compiler will simply strip out these comments when it's compiling your code. So these are only left for you or your team members to read. These only work for single line comments, so if I try to comment here like so, I'm going to get an error. If I need to do multi-line comments, I can do a forward slash star star, or just star, like so. And you can see as I hit enter, it's providing me this way of commenting. When I'm done, I'll just put another forward slash like this, and that's the end of the comment. You don't have to have a star on each line like so. You can just have as many things as you want. And again, this is a multi-line comment. And that wraps up this video on operators. Believe it or not, we've only touched the surface of operators and what you can do with them. There's a lot more coming down the road, and you'll be learning about them in various different episodes in this series. But for now, you should have a pretty good idea of how they work on a very basic level. Well, with the ending of this episode, naturally, I have to give you your assignment. Your assignment is to create a tip calculator. The first variable I want you to do is create a total for the actual amount of a check, say $100, $200, and so forth. Then I want you to create another variable for the tip percentage. So you would have $100, and then you would put the tip percentage, say is 20%. Then I want you to create the final balance of how much you should pay, in which case 20 on 100, this would be 120. You can use floats for this, but one thing to keep in mind, floats lose precision. Typically, when working with money, you should just defer to using ints, meaning you should calculate on cents. But for the sake of this demonstration, you don't really have to worry about that. By using floats, eventually the loss of precision is going to cause people to lose money over time. So the safe thing is to always use integers. For the sake of this demonstration, you don't have to worry about it. You can use floats. If you want to take this challenge up a notch, then have the balance be an integer, and then have the actual tip be a float, and then return the total balance as a float. Well, that's it for this episode. If you have any questions, feel free to leave me a message in the comments, or if you want to contact me directly, you can just send me a message via YouTube. In the next video, we will be diving into arrays, and you'll be learning about how you can use them to store values. See you then.